Lesson is on order of operations and it's on exponents. And then at the end, we'll do order of operations with exponents. So when we talk about the topic of exponents, the topic really should be called powers. So a power is made up of a base number and an exponent. So in this example, the base is 2, the exponent is 3, and that 2 with an exponent of 3 is called 2 to the third power. So this is really a power, but it's commonly referred to as the topic of exponents. But an exponent is just one piece of it. All right. So the way power works is the exponent tells you how many times to multiply the base times itself. So 2 to the third power, 2 with an exponent of 3, means multiply 2 times itself 3 times. 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. The most common mistake that I see students make is instead of doing 2 times 2 times 2, they just multiply the base times the exponent and they get 6. So remember, the exponent's telling you how many times to multiply the base times itself. So let's look at some examples. So this first example, we've got 2 to the third power, which I didn't mean to make that exactly the same as what we just did. But as we just said, that means take 2 times 2 times 2, which is 8. So a power is just a simplified way of writing 2 times 2 times 2. So instead of writing 2 times 2 times 2, you can simply express that as a power. In math, we try to write things in the simplest way we can. So powers just gave us a simpler way to write 2 times 2 times 2. So 2 to the fourth power would be 2 times 2 times 2 times 2. So in this case, we've got 2 times 2 is 4, times 2 is 8, times 2 is 16. Notice that if you just take 2 to the third power, the answer was 8. If you just multiply that by an additional 2, then that gives you the answer of 2 to the fourth power. So if you were trying to find like 2 to the 12th power, and I told you what 2 to the 11th power was, then you could just simply take the answer from 2 to the 11th power and multiply that answer times 2, and that would give you 2 to the 12th power. All right, these next 4 examples, these are the ones that students have the most trouble with. In this case, number 3, the base of this power is -3. So again, the power is telling you, or the exponent is telling you, to multiply this base times itself 2 times. So that's what we're going to do. Multiply -3 times itself. And remember, the rules for multiplication are if the 2 numbers have the same sign, then your answer is positive. So this comes out to +9. So the base is -3. I'm multiplying it times itself 2 times. So -3 times -3 is +9. So what's the difference between number 3 and number 4? Well, there's not parentheses. And those parentheses are called grouping symbols. And what they're doing is grouping the negative sign and the 3 together. And you can see the exponent is actually on the parentheses. So what it's telling you to do is take whatever's in this parentheses and multiply it times itself this many times. Whereas over here, the exponent is on the 3. So the 3 and the negative sign are not connected together. They're not grouped together by parentheses. So in this case, our base is simply 3 and not the negative sign. So what about the negative sign then? So the negative sign just comes along with our answer. We just bring it over here. And then we do 3 to the second power. So we do 3 times 3. So 3 times 3 is 9. And then again, the negative sign just comes along. And so the answer to this is -9. Okay, so I know that's confusing to a lot of students. It's all about the base. This is where I usually break into song and sing all about that base, but I won't do that because I don't want to scare you away. So in this one, the base is -3 because the exponent is attached to the parentheses. So So the base is whatever's inside these parentheses. On this one, number 4, the exponent is tied to just the 3. The negative sign is just kind of sitting there in front. So you just do 3 times 3 and bring the negative sign along for the ride. All right, so similarly with number 5, the base is -4. And so the exponent is on the parentheses. So you need to multiply whatever's in the parentheses times itself 3 times. In this case, we're going to multiply -4 times -4 times -4. -4 times -4 is +16, because a negative times a negative is a positive. They have the same signs. And then you're going to multiply that times -4. So now you have a positive times a negative. So you're going to get a negative answer of 64. Now, one shortcut you can do when you're multiplying several numbers together and you have positives and negatives, if you count how many negatives there are, an odd number of negatives results in a negative answer. If you have an even number of positives, you're going to end up with a positive answer. So you can see up here we had 2 negatives. That's an even number. Our answer was positive. Here we have 3 negatives. That's an odd number. So our answer is negative. Okay, you can use that for anything. So if you have a bunch of numbers multiplied together and 7 of them are negative and the rest are positive, 7 is an odd number, so your answer is going to be negative. If you had, let's say, 20 numbers being multiplied together and 12 of them were negative, 12 is an even number, so your answer is going to be positive. All right, so again, over here, last example here, number 6, the base is just the 4. So the negative sign and the 4 are not grouped together with the parentheses. So the exponent is really just on the 4, and the negative sign is sitting there. So the negative sign just comes along with my answer. And then I have 4 to the 3rd power. So that's 4 times 4 times 4. So 4 times 4 is 16 times 4 is 64. And again, the negative sign just comes along for the ride. Now, notice that we got the same answer here, yet on 3 and 4, we got different answers. Okay, so sometimes, well, particularly when you have parentheses and not parentheses, if this is an odd number, the exponent, the answers will come out the same. If it's an even number, your answers are going to come out differently. Okay, so I know this difference confuses my students quite a bit. So you might want to just back this up and just listen to it again. Let it sink in. Maybe watch it a couple times, just that little section. All right, so let's throw this together with order of operations. But first, I want to talk about how we show division in algebra. So how can we show division? Well, in elementary school, most of my students are 7th graders. 6th grade is in the elementary school. Most of them have only seen division written using a division symbol. So 4 divided by 2 equals 2. Well, in algebra, we don't use a division symbol as much. I mean, you will see it, but more commonly what you see is division written as a fraction. So this 4/2 is the same thing as 4 divided by 2, which is 2. So this is the way that you're going to see division written most of the time in algebra. A lot of times my students freak out and they say, oh, I hate fractions. Well, it's nothing more than division. That's all I'm asking you to do is divide these. All right, so let's throw this into some order of operations. I think I got 2 examples for you. All right, so remember with order of operations, we're using Pemdas, and remember I write it like this because multiplication and division have the same level of importance. So you do whichever one comes first, and the same is true for addition and subtraction. So again, this line here, this is a fraction. And all this is saying is take the top here and divide it by the bottom. Take the top and divide it by the bottom. Well, before we do that, let's simplify the top and simplify the bottom using order of operations. So in the top, I have multiplication, addition, multiplication. So multiplication comes before addition. So I'm going to do the 7 times 2, and I'm going to do the 6 times 6 first. 7 times 2 is 14. 6 times 6 is 36. In the bottom, I have subtraction and addition. Remember, do subtraction first because it comes first. So I'm going to do the 10 minus 6 is 4, and plus 1, and then this. All right, so let's finish simplifying this up top. Again, I got the 14 from 7 times 2 and the 36 from 6 times 6. And I did those first before the addition. Multiplication comes before addition. So let's add the 14 and the 36 together. That gives us 50. In the denominator, I have 4 plus 1 is 5. And again, freak out and say, I don't like fractions. I know you don't, but this is really just nothing more than division. You're just taking the first number, the numerator, the top number, and dividing it by the denominator. So all you're really doing is you're just doing 50 divided by 5. So 50 divided by 5 is 10. And now last thing we're going to do is this plus 2. So 10 plus 2 gives me 12. So again, when you have a problem that's set up like this, simplify the top using PEMDAS, simplify the bottom using PEMDAS, then divide them, and then the last step was to add the 2. All right, so let's look at one more example here. So again, this 15 over 5 fraction here is really nothing more than 15 divided by 5. All right, now this one, so you have 8 times 15 divided by 5. So if you're following well, I should do the parentheses first. Let me back up. I got ahead of myself. Let's go through PEMDAS. Learn from my mistake. PEMDAS, first thing you should do is look for parentheses. And there are parentheses. So let's do that first. Okay? So let me back up. I tell my students to be methodical about this, and I caught myself not being methodical. So 2 plus 1 is 3. And we have an exponent of 3 here. Okay, the parentheses are gone now. Now next is exponents, and we have an exponent here. So remember that means 3 times 3 times 3. The base is 3. You're multiplying times itself 3 times. So I'm going to bring this down. 8 times 15 divided by 5 minus 3 times 3 is 9 times 3 is 27. Okay, so now I can get back to what I was trying to start with that I shouldn't have started with. I've got multiplication and division. And so normally I would tell you the multiplication you do first because it comes first. But if you're going to multiply 8 times 15 fifths, wouldn't it be easier to first simplify this 15 fifths to 3? So that's what we're going to do. So we're actually going to do this division piece first. So that's going to give us 8 times 3 minus 27. Now I have multiplication and subtraction. Multiplication first, so that's 24 minus 27. Remember, you can change fraction into addition. So we're going to keep the 24, change the minus to plus, and then you have to take the opposite of what comes after it. So you have to change 2 things. You're going to keep it, change it, change it. And so then the 27 becomes negative 27. And now we can follow our addition rules that say if these 2 numbers have signs and you subtract them, so that would be 3. The larger number is negative, so the answer is -3. All right, so if I went too fast on any of these things, just remember you can back it up. Just watch the little sections that you need to again. So until next time.